this weekend is the solstice on the 20th. And what the solstice is the longest day of the year, or the shortest day of the year. So there's if it's your winter solstice, that's the shortest day of the year. The summer solstice is the longest day of the year. The equinox, by the way, that's the day where equal nox, night is equal, equa, nox, night. Night is equal to day. So, and what we're going to do is an international nature journaling event on that day where all of us will independently be documenting what we see in the sky from our latitude. And what it's going to start with is hold on a moment. Let's see here. I'm going to bounce over to the webcam and show you this. Melinda, are you seeing
I'm seeing cheetah.
All right, there's our cheetah friend. I think I've got a lot of the resolution problem solved. I'm getting a better image on the webcam these days. But that's from our cheetah workshop. This is what I went out recently to the playground behind my daughter's house, behind our house. And this is the page that I've created for myself. And what I have across the bottom is in 20-degree increments from 0 degrees all the way to 360 degrees on the other side. So from north 0 degrees all the way to north 360 degrees. That puts south right in the middle, east and west. Going up the book, I have 10 degrees in the sky, 20 degrees higher, 30. So degrees in the sky is a way of measuring how high something is. And what I'm going to do on the solstice is I'm going to go out, and when the sun comes up in the morning, I'm going to look around and I'm going to see where the sun comes up. So let's say the sun comes up here. I'm going to write down, I'm going to draw the sun in here, and I'm going to write what time I see it coming up. And then I'm going to go out a little bit later, and I'll see the sun somewhere up in the sky. And I'm going to figure out what point in terms of 360 degrees, what's the point on the ground directly below the sun, and how high that sun is in the sky. And then I'm going to draw it in my journal here. And then I'll come out later and do it again, and later and do it again, and later and do it again, and later and do it again, all the way until sunset. And what I'm going to do is get an arc across the sky of the position of the sun at my latitude. And so at specifically where I am at this latitude and longitude, this is what my sun does. And if I were above the Arctic Circle, it would do a totally different thing. If I were in a different part of the country at the same latitude, the same height on the globe, I would have the same pattern in the sky, but the times would be different. And if I am at but if I'm at a higher latitude or a lower latitude, the pattern that it's going to make is different. And similarly, the pattern that it's going to make if I'm in the southern hemisphere is going to be totally different. So what we're going to do is everybody's going to track it. And then we'll get together and compare our notes and see what different patterns were made in different parts of the world. Essentially what you're doing is you're turning your journal into a henge. right? A hinge is a tool for measuring the positions of the sun in the sky. Stonehenge we're all familiar with. This is paper hinge. And it's going to be your own hinge. So how I did that, how I made that, is I'm going to, let's say this is my journal, and right here is the middle of my journal. All right, I'm going to do that a little bit darker so everybody can see it. So I'm looking at one set of facing pages in my nature journal. Is anybody who is tuned in right now, is anybody here in the Southern Hemisphere? If so, unmute yourself, wave, let us know. It looks like we're all Northern Hemisphere. All right. What I'm going to do is right here in the middle is south. And right here on this side is north. And over on this side is north. So if I took these two north sides and put them together to make a tube, I would have a 360-degree thing. All right. Between these two, right in the middle of this, is east. And west is going to be right here. And so north, south, east, west, people who look at map and compass things, they've divided the compass rows into 360 degrees. So that means that south is at 180. This is 0 to 360. All right. That means right here at east is 90 degrees and west is 270 degrees. And if you want to just leave it at that, you can. Or what I did is I just put in a series of regularly spaced marks and used those to measure it a little bit more specifically. So on mine, I've got 0, 20, 40, 60. So I've got sort of 20-degree jumps. And that's going to help me be just a little bit more precise when I'm out there. The other thing that I've done here is I've drawn a little landscape of when I'm sitting in the middle of the playground in my daughter's school, or not the school next to our house. Here's the school. Here's the big tree. Here's the basketball hoop. This is a 360-degree picture of what I have. So I looked at, what do I see? What point is due south? I got a compass and I figured out what point on the landscape is due south. And let's say south happens to be, there's a big oak tree out there. And next to that, there's another oak tree. There's nothing right at south, but this is what I'm seeing on either side of it. And then I'm looking back here to the west. There is a little mountain range coming down. I'm just imagining what might be in, your, if you go out to an open space, over here is where those little farmhouses are, right? But what you're going to do is draw a 360-degree landscape drawing of what you see on the horizon in an open space near your house, a place that you can get to safely and easily on the solstice. That could even be on your patio. But looking all the way 360 degrees around. And then going up, I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90. So here's 10, 20, 30, 40, You can't, so 90 would be the point directly over your head. 90 is directly overhead. This is your zenith. Zenith is the point directly over your head. And then on the 20th, I'm going to get out there and I'm going to look at where the sun comes up. And let's say I get out there and at 6 in the morning, the sun rises, right? And it rises right behind these buildings here. I'm going to draw in a little sun here. I'm going to write 6 a.m. And there's my sunrise coming up. And then what I'm going to do is I'm going to go out a little bit later, and the sun will be higher in the sky, but it also will have moved further west. So the sun, in the northern hemisphere, the sun moves from the east to the west throughout the day. So it'll be somewhere along here and somewhere along here. I'm going to figure out where the sun is. What is the point along here? And I'm going to draw in, this is at 8 a.m. So 2 hours later, I went out and I find this. And then I got really distracted and didn't go out again until noon. And when I was making my sandwich, I realized, oh my goodness, right? And there's 12 noon. And then some point later in the day, I'm going to do the same thing. And later and later until I'm going to get one point down here that is my sunset. So what I'm going to get is an arc across the sky of what the sun does at my specific latitude and longitude. On the longest day of the year, the day that the sun climbs the highest in the sky from where I am in the northern hemisphere. And then what the people in the Nature Journal Club are going to do, we are going to do this at the next equinox. So at the next equinox, it's going to be rising and setting in a different place. No spoilers here. And on the winter solstice, rising and setting in a different place. And the arc is going to be a different height and the locations are going to be a different height. But by doing this, you're going to develop a fundamental personal understanding of what the sun does in the sky right where you are. Now, let me talk a little bit about estimating the height in the sky of the sun. This, where it is sort of north to south, that point, right? You're going to come out to that point there and then up. That's pretty straightforward. What you can do to get that point, the little point along here, is all you have to do is look at where the sun is and draw a line straight down to that point, which works when it's rather near the horizon. When it's higher in the sky, you'll find that's difficult to do. So a better approach when it's high in the sky is you put a vertical stick in the ground and it's going to cast a shadow. The direction, then you look at what direction that shadow is pointing, and that the shadow will be pointing to that spot on the horizon, which is going to be your degrees. So up from that, the right height up. Now you're thinking, well, okay, I can get this by following the shadow. Shadow of a vertical object is going to point to this point here. How do I get the point in the sky? I'm going to turn back to this other camera. And this is where 1 potato, 2 potato, 3 potato, 4 comes in. And what you're going to do is, do you remember when the Three Stooges used to do this? And they're kind of make it who gets the object. first person holds it, the next person holds here, the next person holds here, and somebody's left with the pencil. What you're going to do, if you stand facing the sun and you keep your shoulders square with your back to the sun, and you take your hand and you bring it just so the bottom of your fist is straight, it rests on the horizon, right? Rest the bottom of your hand on the horizon wherever you're seeing, right? And so the horizon, again, would be the projection of where your eyes are out to as far as you can see. So wherever your eyes are, that is the height of your horizon where you are, right? So out there, all right? So your height of your eyes. And you put the bottom of your fist on that, and then that height of your fist at arm's length is about 10 degrees. And so then what you're going to do is 10 degrees, 20 degrees, 30 degrees, 30, and then the sun is a little bit above that. All right, so about halfway above that. So 30 and a half or 35 degrees, that would be, right, so if I did 3.5 fists up, that would be, on my chart here, I'd go 10, 20, 30 and a half. That would be that height. So that doing this thing gets you up in the sky, and looking at which direction the shadow is pointing gets that point along the horizon. I get both of those things together, and you have a way of getting all that information about the position of the sun. And what's going to be interesting is that there are going to be people tuning in from Australia and South Africa and way north in Alaska, all over the globe, doing the same thing. And that is, we're going to be able to compare what they get, and you're going to get a completely different understanding of what the seasons mean and what the sun does in the sky. The ancients really paid intense attention to this. If you were an agricultural society, you had to pay very close attention to when the solstice and the equinox was, because your timing of when you're going to plant and harvest depends on that. If you get off of that schedule, then you're planting your plants at the wrong time. It's not going to end up well for you, right? So anybody who's still alive probably descended from people who paid attention to these things, and so far, and that's why they passed on progeny. The agriculturalists who weren't tracking this didn't leave any descendants. So as naturalists, this is a really fun thing to watch because this is of extreme ecological importance. This is the point where the days have been getting longer, summer, more summer, and now the days on the other side of that, they're going to be getting shorter and shorter and shorter. Interestingly enough, you also going to be able to tell day length from this by looking at the time of your sunset and your sunrise and sunset, and subtracting that from 24, you'll have the length of the day on the longest day of the year, specifically at your latitude, right? Again, if you go all the way up into Alaska, it's going to be different. But we'll have a data set to compare all these journal entries from all over the world. Did that make sense?
Jack, there is one question. Marguerite is asking, she's confused about how to use the shadow in the pole.
Oh, all right. So the shadow can be used in two ways. The one which I just described here is just simply to figure out which direction is the sun from me. If the sun is low on the horizon, you just point to the sun and drop a line down from it. But it turns out when the sun is way kind of up there, it's hard to say, well, is that the way down from the sun, or is that the way down from the sun? It's the higher it gets, it becomes difficult to see what is the shortest line. Of course, if the sun were directly overhead, it would be even in all directions, right? If it is close to overhead, it'll be confusing to figure out which direction is the shortest line down to the horizon. So that's why I put a stick vertically in the ground. It will cast a shadow out behind it. You draw a line up the shadow through the stick, and that will be pointing in the direction that is the quickest line, the shortest line down from the sun. That is the direction on the ground that is what you're going to use as your point in terms of 360-degree compass. All right. In the other workshop, I also showed a technique using the shadow of a stick to figure out how high in the sky the sun is, but I think that confused a lot of people. Mm-hmm. So for this, I'm just pointing it out as a way of figuring out which direction is the sunlight coming from, because you find where the shadow is, draw a line through the shadow, up the stick, that's the direction of where the sunlight is coming from. If you're interested and want to figure out, other than the potato method for figuring out how high the sun is in the sky, there is a really cool way using trigonometry to get that. And I can explain how to do that here. But again, the easiest way, if this trigonometry stuff, you start to, right? Don't worry about it. Go with the potatoes, right? But I actually do encourage people to mess around with this method. Mess around with, if you can, are willing to give it a try. Try some of this, figuring out the height of the sun using trigonometry, because it's a wonderful chance for us just to play with mathematics that we may not have a regular opportunity to do. And the more we get our brains to do different weird things, it's going to make math more fun, a little bit demystified, and also it stretches our brain in ways that kind of help our neural development. So if we want to keep our brains frosty, we want to do different weird things, like what's the last time you did trigonometry, right? But what if it's over on the solstice? So let's do some trigonometry together. Ready? Here we go. So this is what it's going to look like, and it's going to be kind of fun. I think you'll like it. Right. Here we go. Here is the stick in the ground, right? And I am drawing this from kind of a perspective view. All right, there it is. It's in the ground. Here's the ground, right? Now the sun is off somewhere, and this by the way, I put this stick in the ground at a right angle, right? So it is sticking straight up out of the ground. Right? If I do this from a side view instead of my 3D view, I get this. There's my stick, sticking up out of the ground at a right angle to the ground. All right. Now, this stick is going to cast a shadow out on the ground. If the sun is over here, this stick casts a shadow. And if I put that shadow in on here, that shadow, let's say, is that long. Okay? So my stick here, my stick, I'm doing the stick blue, I'm doing the shadow red. All right. So you see what we have so far? Vertical stick and the shadow. So I'm going to call the length of my vertical stick A and the length of my shadow B. So B is the length of this. I'm going to get out a ruler. I'm going to measure this. I'm going to get out a ruler. I'm going to measure that. So I've got A and B. Now, check out this math problem. I'm going to do A divided by B. Another way of writing this is A divided by B equals. Right? That's going to give me a number, right? This number is called my tangent. And what I do is I go online and I download a tangent table. So this is a tangent table, and it has the tangent, and it has the other column is the angle. So what this means is that, let's say I did A divided by B, and I got 3. I got 3. All right? Or maybe I got 3.4, right? All right, so I get some number. I've got 3.4. My tangent is 3.4. I then look down this until I get to 3.4. Oh, here it is, 3.4. That means that the angle is 19 degrees. So what that means is I'm going to go back here, and if you were to draw a line from the end of this shadow to this top of this stick right there, that line would point right to the sun. And what is the angle here? Well, I figured out the tangent was 3.4. That meant that the angle was 19 degrees. That means that this angle is 19 degrees. And so what I do is I would go 10, 20, so a little bit less than 20, and I would bring that over to wherever I was. Say that was, I had a point on here. I now know that I go 19 degrees up into the sky. That's where I'm going to put this one here. And I would say, I would write in that that was at 7 a.m. and I might even write in that it was 19 degrees. If calculating with the tangent doesn't seem like it would be fun to you, then that's where you can get also the height in the sky by doing the potatoes, right? Fist, bottom of your fist on the horizon, where the top of your fist is, that's going to be 10 degrees, 20, 30, 40, right? So by doing that, you can get the height in the sky if you don't want to mess with the tangents. But again, why not give it a try? I had fun. Like, I'm thinking, like, what's the last time I did something with tangents? It was back in the Pleistocene when I was in a trig class, and I didn't remember any of that stuff. And so I looked it up again, and like, okay, you get this table, you download this table, and you look up the number in it. And so that's how I figured out how to do that. It's pretty cool. So again, you need two things. What direction and how high. The potatoes and the tangent thing can tell you how high. You can also use the shadow, because you draw a line through the shadow. You draw a line through the shadow, through the stick, and that direction is going to point towards the point on the horizon that will be the closest, the spot right below where the sun is. So again, when the sun is high in the sky, it can be sometimes hard to figure that out. The shadow will help you. Margarita, did that make sense?
Yes, very much. Thank you very much. I now catch on and I know what we're doing and I'm excited about it. Thank you.
Oh, good, good, good. So yeah, this is going to be a weird thing. It's going to get you thinking about the sky in a way that perhaps you have never thought about it before. And it's also going to be, the real kind of magic of it comes in when at the end of this, you're going to be able to compare your chart with somebody in Alaska and somebody in Australia. And you'll be like, whoa, whoa, there'll be these weird things. And if you have your own chart of what it's doing right where you live, that's going to be fun. That's going to be really, really fun. So we're going to have a Zoom meeting where everybody's going to get together. We're going to share our documents, and we will, spotlight ones from different areas. Any other kind of notes or things that you can make, share those. Now, if you are, I'm recording this, by the way, and I'm going to put it online. If you are in the Southern Hemisphere, your chart is going to look a little bit different than this one that I just set out here. So let me just sort of show everybody. So for people who are in the Southern Hemisphere, imagine this is their journal. They are going to have, instead of south in the middle, this is where their north point is going to be. That's going to be north. And they're going to split their book along south and south. And over here will be the east. Over here will be the west. All right. So this is Southern Hemisphere. So if you're in the Southern Hemisphere, you're going to set yours up like this. Everything else will be exactly the same. You want 360 degrees along the bottom. You want up to 90 degrees going up. And then you'll be able to compare yours. And it'll just be very interesting to see the behavior of your sun in the sky compared with Northern Hemisphere people. And you can actually do some thought experiments before the date, thinking like, well, how would that look if I were in the Southern Hemisphere? Or you can just go ahead and wait for the reveal when we all get together. Does anybody else have any questions about the Solstice project?
I have a question. This is Melinda. So I live on a hill, and south facing is a downslope of our property. So I'm not exactly sure what the elevation is from the horizon line, but I'm thinking that it doesn't really matter as long as I do this consistently from my back deck facing south, and I do this now and at the equinox and at the next solstice. I would just compare how it changes in my location from that altitude. Is that correct?
That's right.
Yeah.
So I'm going to pretend I'm now transporting your back deck to a sort of steep hillside, right? And I'm going to put you in the Southern Hemisphere. And I'll show you what you might get on, all right. Now, your view, let's say do you look out to the west or the east, or what direction?
I'm looking south.
Okay.
Almost
so
directly south.
I'm in my little fantasy drawing here, there's going to be some distant kind of mountains out to the south, and I'm going to see those kind of coming in over here, and right behind you in the north is actually your house, and there's that little door over there, and so there's, you know, part of your view this direction may be some object that is part of your house. So as you're looking, you know, the part of your house, of course, that would be, you then on yours, because you're in the northern hemisphere, you'd have your house kind of looking out this way and be looking out to your view here. So you'd have parts of your house showing up in this 360-degree view here. If you're looking out that direction in your southern hemisphere, of course, then that means that the house is in the center of your picture. But yours, with your north house, your house behind you, you'll show some of that in your porch and kind of the entry to your porch, and, you know, other things, and then the tree that'll be over there. And, you know, the you can also do the potato thing to see how high to draw those trees. So just sort of sit there and you're looking at it, at a tree that's out on your back porch, and you kind of look, it's a really, really tall tree. You do your potatoes, you go up 50. You may then on this, you're going to kind of go up 10, 20, 30, 40, 50. Okay, that means that tree, I'm going to draw it actually that big on my picture. Right. If there's a big tree that's near me down here, you know, it might be something that kind of comes up this high, and I'm just going to do the 1 potato, 2 potato, 3 potato. On that one, it went all the way up to 35 degrees. Right. So things that are further in the background are going to appear smaller. Take a look at this. When I was sitting there in the middle of the playground looking around, I had some trees. This one was closer to me. Because it was so close to me, it went all the way up to almost to 30 degrees where I was. So it ended up being bigger. But these other big trees way back here ended up, I did my potato on them, and they were, you know, just a little bit over 1 fist tall. But this one, because it was so close to me, I went up almost 3 fists. So you can put, you know, other features. My basketball, if this basketball post here was even closer to me, it would be show up as higher on this page. It could be that big. Or if I was right underneath it, it would go off, it would go all the way up, right? But I wasn't that close to that basketball post.
Yeah, it gives a sense of perspective when you do that.
Yeah, it was weird to do this because it really got me thinking about how big is that thing really from where I am. And so it kind of, just doing this was an interesting project, kind of getting all the different features at different points. So you can just sort of at your leisure, but before the solstice, kind of map out what your backyard, or if there's an open space that is fairly close to you that you can get to, you can do that. And then you're going to get, this will be your own henge. And you'll probably have a landscape that is more scenic than this. This is kind of me with the constraints of COVID. I'm going to go into this abandoned playground. And so I basically have, you know, I wish I was in a place where I had mountains and, you know, Fairview Dome over here, mad points for anybody who's in, you know, it wouldn't be fair to be in Tuolumne Meadows right now, but my dream would be to get to do this in the middle of Tuolumne Meadows. Wouldn't that be great? Oh. But I'm in San Mateo. Did that make sense, Melinda?
Yeah, it did. It did. I just forgot that I need to go into an open space. So I think I just need to leave my deck and just go down into our pasture. And it's still on a hillside, but I think I can figure this out. So the house, because the house is directly behind me, it would be showing up on both the left and the right hand side of the page.
Yes.
So, yeah, I get it. Thank you.
Absolutely.
If we do this every 2 hours, is that a close enough frequency?
Oh, that would be plenty close. And what's going to happen is you'll probably do a bunch right at the start, and then in the middle you'll forget, and then there'll be a big gap in your data set, and you'll be like, oh no, and you'll get out there like, how did the sun get from there to there? And here's also kind of a fun thing about this, is that everybody is expecting, what time will the sun be at the highest point? What time will the sun be at the highest point in this process? Anybody take a stab at that?
About noon.
That's what I would expect.
But with daylight savings, is that
I
shift?
think it's different.
And that's going to be another thing that's going to be really cool to see. Watch as you get to the middle of the day, perhaps have a few more right in there, because there is a subtle weird thing that you may be able to record. And the reality that you record may not match the expectation that you have right now. No spoilers on this, but if in the middle kind of high point of the day, you're trying to figure out when is solar noon for you. When is your solar noon? Solar noon is when the sun is at the point that was the closest to directly overhead. It's been going up, and after that it's going down. So you're trying to figure out when is your solar noon, and everyone says, of course, that's going to be at noon.
So I put it in my calendar for every 2 hours, and then I put 3 times clustered around the middle of the day.
That'll be cool. And don't miss that sunrise and sunset, because that just like, it starts it off, it wraps the whole thing up, and you kind of get like, pow, ah. When the sun goes down that day, then you get to draw in your line. You go like, ah. There you go. Now, if we get somebody who's above the Arctic Circle, it's going to be crazy. It's going to be a crazy diagram. So that I'm really hoping that we get somebody who's that far up on our planet. And then you're thinking, then what exactly is the Arctic Circle? So I've heard of the Arctic Circle before, but what in terms of light in the planet, what defines that point? There's something called the Arctic Circle, and why is it you're above that line on this date, you're going to see something nutso that's different than everybody else will get, all right? Quantitatively different, profoundly different than everything else that everybody will see. If you're above the Arctic Circle, ooh, you get a crazy one. All right.
I have a question about what's the best place to find out what the longitude and latitude is here? I mean, where are we at?
So one way of doing that is just type longitude, latitude calculator into or name your city and put that into a web search. And there are search engines that will say, here are your coordinates.
Okay,
all right?
Great, thank you.
Use
that's where I did mine.
Google Maps.
Google Maps, we'll give that to you.
Yeah, it'll tell you where you are.
And here's another fun thing, is take a look at that, and it'll be a bunch of numbers. Bonus points if you can get out a globe and start to make sense of what those numbers actually mean. Because it's one thing to say, my latitude, longitude is, like I've got written in my journal, my latitude is 37 degrees, then 33 line, right? 15.0084 line north, like little quote mark. Like what do those mean? And what does that actually mean? How is that being calculated? So if you kind of start geeking out on this, another thing that kind of fun rabbit hole that you can go down is when, instead of having a, otherwise, you kind of look at your latitude and longitude, and you say to yourself, right, you might as well say, oh, those are a bunch of numbers, and I know it's supposed to be important for some reason, but I have no idea what it means. It might as well just say my latitude is blah, 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 right? But can you actually decode that and look at, like, you know, how do you do that? If you don't have a compass, your phone, you can download an app with a compass on them. I found that when I did that, that there's a certain margin of error that can be, for the precision that I was going to, I found it a little bit frustrating. Because I would first I did it with I have my little phone, and I've got my app there, like, okay, this is gonna be easy, right? So I lined it up, right, that's south, okay, then I would draw things out from there, okay, that's right at east, and I'd kind of draw things out from there, and then things weren't fitting, and I went and I went back and like, oh no, east is actually over there, okay, so I had to erase, and then get back in there and like draw all these things out, like then things weren't fitting again. I'd look at it like, no, east is actually over there, and so like east was going like, right. So then when I used I then decided I'm just going to go old school on this, and got out, there it is. I got out a compass and did it with the compass. And then east was holding still. That was nice. So if you are using a real compass, a couple of things to bear in mind is thing number one is that your compass needle will point different directions if you are near something with like a big metal object or a strong electromagnetic field. So if underneath the patio where you are, there's a bunch of wires going through, that might mess up your compass needle. Similarly, if there's a big metal object down there, my scoutmaster always used to tell this wonderful story of, he set up this orienteering course and gave maps to all the Boy Scouts, and they all had their compass, and you know, we took our bearings and we started off, we all had the same route, we're going to follow the same route, we're all in the parking lot. And what the Boy Scouts did is we all looked around and we all found nice flat places to lay out our maps, which is on the hoods of all the cars. So all the Boy Scouts put their maps down on the hoods of the cars, then put their compasses on top of that, oriented the maps. Each map was pointing in a different direction because the magnetic anomaly of the car itself. And so because they had put it on the cars, every group of Boy Scouts then took off in a completely different direction to go find this sort of mystery spot. And you're just like, oh, okay. So a lesson learned. So the other thing with a real compass is that your compass points to magnetic north, which is different than true north, north on the North Pole. There's something called the declination, which is the difference between true north and magnetic north, and that will be different for different spots all over the Earth. So on a regular basis, USGS and other folks, they figure out what is the magnetic field of the Earth doing, and they're saying, for this spot on the Earth, you're either going to go this much more or this much less to calculate, to take into account the difference between magnetic north and true north where you are. And so find out what your declination is. That's that number that gives you the difference. And when you're trying to find true north, you can program that into your compass and then figure out what true north is. And if that sounds like too much of a hassle, then just have a note written on your journal page that all of these degrees readings are using magnetic north. Right? I'm using magnetic north for all of these. And so that later on, you can look at that and kind of be like, oh, for all of those, all you'd have to do is just subtract 13 degrees or add 13 degrees. Where I am, I add 13 degrees. And that gives me my readings. But if you are using a compass, this idea of declination is another piece that comes in. So you see what's going on here. This little kind of weird thing of like, what's the sun doing? It starts to balloon. Now it's bringing in the magnetic field of the Earth, trigonometry, and all of these other weird things that we normally don't think about. But when we start geeking out like this, it's all there, and it's fun. And it's fun. So this is going to be a big time geek out fest. We're just going to get all nature nerdy out there, kind of going like.
Okay, I have a question. What about little kids? So I've been introducing a lot of young children to observing nature and trying to sketch, and this is all too much for a 3-year-old and a 5-year-old.
Is it? Because the idea, hold on, wait.
I want to simplify.
The idea for this project came from my daughter is in 1st grade, and her teacher had the whole class do this project where they mapped the position of the sun in the sky. They went out, they drew a picture of the landscape, and they went out and they drew the sun at different times in different places. So without all this measurement and stuff,
right?
If the kids go out and they do a little, it's a fun project. Let's do a landscape drawing that's all around us, right? So I just want to send a shout out to Mrs. Olsen-Mendy out there for giving me the idea for this project from the science project that you had the 1st graders do. So you start with this 360-degree drawing, and then where's the sun coming up, right? And then, oh, look, now where is it? Oh my gosh, it's all the way over there. And you'll get, it doesn't have to be as precise, but they can get the sun came up over there, and it's going down over there, and it was high in the middle of the day, and it did that. Wow. Okay,
so that's great. That's what I was thinking, because for me to explain trigonometry to a 3-year-old would be super challenging, but more for them to get to noticing, hey, the sun moves, and it has a different relationship to the tree that they normally see that doesn't move. That's more what I was trying to get them
also
to
they will get into is in the morning, get a piece of chalk and draw the shadow of the vertical post on the ground, right? So I'm going to jump over to the little thrill cam here. All right, so let's say this is your post really on the ground, and in the morning the sun was over here, and it cast a long shadow out this way. Right? Now, as the day goes on, the sun starts, it's going to move across this part of the sky. And so just like a clock, this is going to, this shadow is going to move like the hand of a clock. But here's the other cool thing, is that in the middle of the day when the sun is higher, that shadow is going to be shorter, right? And so what they're going to get is something that they're going to get some little drawing with chalk on the ground. And isn't that a cool little pattern?
Yeah, I like the chalk idea. Thank you.
Yeah, so this, Mrs. Olsen-Mendy, she had us, she had her 1st graders out there observing sun positions in the sky. And we got up early, we went to bed late, and it was profound. And both of my daughters, actually, I'm going to just run away for a minute. I'm going to come back with something cool.
It's going to be so much fun.
I'm coming back. Check this out. So this was, I thought it was such a, this is, oh, it's not going to really show up very much here, but you can see the sun coming down here. It's going across the sky up on the top of the page, and over on this side, it's rising, and then it got up to here. Made us wish that we're missing a few big spots in there because we weren't as consistent as I would have liked. But what we get is this big landscape across the bottom, and then we have this big. Maybe it's too washed out there to see. Does it just look like a big piece of white paper?
Yeah, we can't see the sun marks, but we can see the landscape, the horizon.
But you know, there's a little sun mark, and you know that's pretty cool. That's interesting. So I would just start with a 360-degree sketch.
Okay.
And then kind of get out there and, you know, this is what Olsamendi had them do. Is she had them say, this is low, right? This is medium, and this is high, and then very high. So she had these little arm positions that you do, and you just take your arm and you do this motion, this motion, this motion, or this one. You know, which one is it? So you point your hand out at it, and then that helped them sort of, you know, they just had 4 categories of sort of where the arm position would be. You're pointing at the sun, and that was how they were. So instead of, you know, potatoing the degrees or anything like that, they were just using their arm with 4 different positions. That might be also kind of a useful thing to throw in.
Thanks, Jack. Thank your daughter's teacher.
Yeah, so Mrs. Olsamendi, if you're out there, mad points. She's just retired, spent a lifetime in education, sometimes as a school administrator, and then ended it with a bunch of time in as a first grade teacher. You know, that really just shows a commitment to education and to you know, that is noble. That is noble. Really brought generations of kids into the world of learning. I've got just such deep respect for her and other educators who are doing working with their family or with a classroom of kids that are not theirs. It's extremely difficult work. A lot of people are just happy to have somebody else handle all the education stuff, but willing to sort of stand in that fire and step up to that responsibility. It's huge. So just, you know, deep respect to all the educators out there.
Yeah, well, I homeschooled my daughter when she was little, and I've worked from home for 30-something years, and then I have all these clients who now are working from home and stressed out about how to help their children. So I've been sending them activities that they can do with their children, which gives them a break from their stressful work life and gives them more bonding with their kids and introduces them to nature. So I wanted to give them something else to do. So I think this will be a great project. I'll send it to them. I'm their their parents' executive coach. You know, these are high-level senior people in organizations, but they didn't know how to homeschool their kids.
That's great. That's great. Well, thank you for doing
Fun.
that.
Fun for me. Thank you. This was great. I'm glad you did this impromptu session with us. Thank you.
Yes, thank you so much. This was really informative, and I liked hearing how to teach the young children.
Yeah, I think it's going to be it is so rewarding to have a chance to do this with your family or with any kids, where you kind of see these aha moments, and also that the other part of this, you get this down for the solstice, the longest day of the year here in the northern hemisphere. When they go and do this again on the equinox, and they start seeing that the times are different, the height is different, and then you ask, what do you think it is going to be like on the winter solstice? And try to get them to predict what the pattern is going to be in December. Like, that's really cool.
And
that's really cool.
And then they can test their hypothesis by actually doing the exercise again in December and comparing the two charts.
Bingo. And you'll have it all on, actually you can put it all on the same chart, just using a different color for each of those events.
Or on tracing paper that you can layer over a drawing, so that you can lift off the different.
Yeah, that would work well too.
Okay.
I'm just going to draw it in on mine. I get it, different colored pencil and get in there. That's
okay.
This is going to be a beautiful event. And then just imagine other people doing this all over the world, and then you're thinking, like, what would this look like in Australia? And then here's what it looks like in Australia.
Yeah. And when are you going to do the everybody look at everybody's chart?
Yeah. What I'll do is probably either that Sunday, so the day after, or so that'll be up on my website soon. It'll be the solstice review, where we'll kind of get people with their notes from all over the world, and we'll kind of hear from different people, and start thinking about, like, how will this be different in the southern hemisphere, and try to, like, visually think of, like, here I am on this globe, and I'm looking down this way at the sun is doing this. If I were on here and I were looking the other, like, how is that going to look different on a page? And see how many things you can predict and come up with about how that's going to be different. Northern hemisphere, southern hemisphere, high latitude, low latitude. So closer to the equator or closer to the pole. How is that going to look different? You want to kind of get some expectations in your head of, like, I think it's going to look this way. And then, and we'll see. We'll get to see. It's really fun then to, I'm going to advise you not just to do a Google search and get the answer before we do the project. It's very, very tempting to. But back in the day, we kind of sat a little longer with mysteries, and give this a chance to kind of ruminate a little bit and start thinking, like, you know what? Because it's a visualization challenge, and the process of kind of playing around with your brain like that, I think it's going to be really worth your time.
Jack, did you post in the Nature Journal Club this activity to the others can share?
I did another video with a description of how to do it, and I will also be posting this video with that. I started to write it out, and because of my dyslexia, I found I was just going like, So it's a lot easier for me to show, like, look, I draw these lines here and draw these lines here. And I was, doing all these things like, parallel to that axis, and I just started to turn into like word soup.
No, totally.
And
This
I
needs to
realized-
be a video. Yeah. Yeah. You need to be able to show
Yeah.
people. But I'm wondering if you have it as a post to encourage people to do this around the world. You're talking about we're all doing this. Is this just announced only if people come to the workshop, or because I didn't see it anywhere?
I took the video of how to do it,
Okay.
turned it into a blog post, and posted that blog post on the Nature Journal Club Facebook page.
Okay.
Great.
And I may have even taken the step of turned it into an announcement and pinned it to the top of the announcement list. I hope I did. That would have been smart.
I don't see it. Oh, there we go. Yeah, I see it now. It's up there.
All right. Is it at the top of the?
It is. Marley's got one up on top, and yours is second.
Yeah, I might repin that.
You could, you could probably pin yours to the top.
Let's. You're an admin on there, aren't you?
I'm not.
I gotta make you an admin on there. Would you like to be an admin?
I can help you out if you'd like.
Cool, great. I'll make you an admin on Nature Journal Club.
Okay.
Facebook. You're doing so much for this community. Really, really appreciate it. Does anybody else have any questions related to this?
No, I just want to thank you. You made it so clear. I was confused on Tuesday, but I understand what we're doing, and thank you so much for clarifying and going through it with us, and also explaining to us how to do this with young children at the same time. So thank you.
Great, great. So Eva, is your crew going to be working on this?
Yeah.
We got some big thumbs up there.
We're 9 years old and we understand that, right? Go ahead and tell them. It makes sense to third graders. We'll do the potato method with the 6-year-olds and 9-year-olds, and then we'll do the tangent method with the 14-year-old.
That's great. That's terrific.
Me too.
Yeah, it'll be fun. Like, what is the last time you got to play with? You got to play with trig.
Yeah, we're warming up for that in high school, so yeah, this is good review for me. But the potato method totally makes sense to 9-year-olds, so that's awesome.
Good. And you can also, so the secret for potato is shoulders square back to your shadow, arm totally straight, right? Rested on the horizon, and then you're doing that, right? And just keep one hand still as you bring in the next one. Keep that steady, bring in the next one. And if you want to double check that, you're thinking about that everybody's got different size hands. The cool thing is people also have different size arms. So that means when you've got a smaller arm, you've got the smaller hand on it, and it tends to work pretty well. You can double check your calibration of it to make sure that it works. So you notice right up there is a smoke alarm, right? So what you can do is stand directly under some object, right? That's on the ceiling, and then go on the wall here. I'm figuring out exactly where my eye height is, and I'm gonna put my hand there. One potato, right on my eye height. 2 potatoes. Don't move it. 3, 4, 5, 6, 7, 8, 9, right? So when I do that, I get 9 going up to my zenith. And I also saw there that I came in a little bit over at the end. So it's just a little note to me that my potatoing is a little bit less than 10 degrees. One potato for me is a little bit less than 10 degrees. Generally speaking, you'll just do fine doing that. But if you want to, even calibrate your potato, right, then do that on, and you figure out like, oh, mine is, whatever it is. For folks who are interested in taking this further, astronomers actually have this whole system worked out where for different hand positions, it's different kinds of degrees. See those down there on the bottom? So there, you can also go, but the potatoing is easier. There, you can get into 25, 50, 75. Yeah, that works pretty well for me, right? But I like potatoes because then, that's neat. Got some thumbs up. Yeah, I see some. Wait, hold on. We just actually had the full potato dance. Even in Durham, North Carolina, we're pinning you guys here for just a moment. Let's see that potato dance that you guys are doing. Oh yeah, get down with your bad self. There we go. Very good. Very good. All right, everybody.
Thanks again, Jack. Thanks, everybody. Good to see you all. I'm going to sign off.
Really good to see you, everybody. That was a lot of fun. Melinda, thank you very much.
Thank you, Jack.
Thanks, Jack.
Absolutely.
That was great.
Thank you so much, Jack.
Thank
Thanks,
you.
everybody.
See
Bye.
some of you on
Take
Sunday.
care.
Bye, everybody.
Bye.
Bye-bye, everyone. Be well, be kind.